Okay. So this is video number 3 of the lecture video series on electric field. I'll be discussing about, uh, let's derive the equation that will give us the relationship of the field strength and direction at a certain point at distance r from the source charge. Okay, so let me share again my screen, the one that I want to share. Okay, this one. So at this point in time, hopefully we know that electric field as a vector quantity is the ratio of the force received by a charge due to a certain different source charge divided by the charge itself. Whatever is the direction of F, that's also the direction of the electric field. Now, so what if this time, ano nga yung gusto natin, we want to determine the relationship between field strength and its relation with um, R and another factor or variable na lalabas pamaya. So say for example, we have here a positive test charge, source charge, I mean. So I don't want it to be oblong. Gusto ko square. Ay, sphere. Ayan. Hindi siya nag-auto shape. Anyway, so we have our source charge here, Q. Ayan. We want to determine how strong its field strength is at a certain distance r from it. So say for example, I want to determine this electric field strength at this point. I will call this point as point P. So point P now is our point of evaluation, because that is the point in space where you want to determine the electric field at a certain distance here. Okay? So to do that, we will use a positive test charge. Say for example, so maglalagay tayo dito ngayon ng positive test charge sa point P. It's a test charge. So the distance between the source, this is your source charge, and this is your test charge. So we will determine the strength of the field of the source charge using a test charge. So this is the imaginary line that connects them. So static itong charges natin ha, they are not free to roam around. Okay. So the distance between them, let's call this distance between them as R. So if this is the center, their center, their separation, parang Coulomb's law pa rin, R yung tawag natin. Actually, we'll be using Coulomb's law to determine the relationship here. So, by Coulomb's law, by the definition of electric field, so we say that the field strength, okay, magnitude muna tayo. So the electric field is given by the force over the test charge. So this will give you the magnitude of E. Okay. By Coulomb's law, the force of repulsion between these two, so this will have, this is now the force of the source charge on the test charge. Same and opposite direction, this is now the electrostatic force of the test charge on the source charge. But we are more concerned of the electric field at point P and not at this point here. So by Coulomb's law, so the electrostatic force now between Q and Q sub naught will be given by Coulomb's law, yung magnitude. So you have K and then the magnitude of Q times the magnitude of Q sub naught over the square of the distance between them, which is also equal to 1 over 4 pi epsilon naught, and then Q sub naught over R squared. We'll put this magnitude now of the electrostatic force between these two charges. So I will use the K first. So this will be K. Q1 is the source charge Q, and our Q2 is the test charge Q over R squared. But I still have my test charge at the bottom. So the test charge actually is out of the question. This tells us that the fields, the electric field, yung na-mention ko in the earlier video, the electric field will continue to exist around the source charge with or without the presence of a test charge. So it's clear in this equation here na talagang nawala sa equation, nawala sa eksena si test charge. So we now have the K and then the magnitude of the source charge divided by the square of the distance between the source and the point of evaluation. Itong si R. Okay, so if you look at the drawing here, that's the definition of R. The distance between the source charge and the point of evaluation. So this gives you now the magnitude of the electric field. And then for the direction, okay, oops. Ayan. Let me show first the other way of writing it using the different electrical constant. So instead of K, I can also write 4 pi epsilon sub naught, and then I'll have the magnitude of the source charge times squared. This will now give you the field strength or the magnitude of the electric field. Ayan. Okay, so since electric field is a vector quantity, it's not enough to give its magnitude. You also need to give its direction. So every time you use this, for the direction, you just follow, so direction of E. If the source charge were positive, yan. So dito na yung important principle na ginamit natin kanina. If Q were positive, then direction of E is the same with the direction of F on Q sub naught. But if the source charge were negative, then direction of electric field is opposite to the direction of F on positive test charge Q. So magdepende na lang kung ano si source charge. So in this example here, since the source charge were positive, then this force now will also be the direction of the electric field at the point of evaluation. I'm sorry. Ano na ito? Ayan. Point of evaluation. So this is now the electric field at point P. Okay? The magnitude, ito lang, KQ over R squared. Yan. But if the source charge were negative, then the electric field is into it. So it's in the third quadrant. Okay? Now let's continue. There is another way of looking at this electric field, no? So we now talk about unit vector R hat. So this is in addition to the unit vectors I hat, J hat, K hat, I hat, J hat, K hat that we learned in Physics 1. So let's go back to the same source charge that we had earlier. It's a positive source charge. And let's say my point of evaluation is somewhere here. Or somewhere, sige, dito na lang, somewhere here. This is point P. I want to determine the electric field at P. Electric field, magnitude, direction at point P. That's the goal. Okay, so in this case, with or without the source charge there, I will just have to determine how far is my source from my point of evaluation. So this to that, yan. This would still be by R for the distance, but we have this what we call unit vector R hat. Unit vector R hat. This is in addition to what we learned in Physics 1. You have I hat, J hat, and K hat, remember? So in the discussion of electrostatics, we use unit vector R. Unit vector R points from the source to the point of evaluation. So as a vector, its magnitude, okay, its direction muna, is from the source charge to the point of evaluation. Point of evaluation. So in this case, I have here, this is our source charge. Therefore, I can just draw here a unit vector r hat. I'm sorry. Unit vector r hat. It is directed from the source to the point of evaluation. Now, see, r hat is defined as follows. So r hat is determined by the ratio of the position vector r, yung na-learn natin in the past, where it can have three components. You have xi hat plus yj hat plus z k hat. Yan. So, over the magnitude of the distance between them. So, in this case, if I'll place here my reference, okay, kung saan yung source charge natin lagyan ng reference. So, itong si R now, our position vector R would have this magnitude, this length, and then the direction is either this angle or this angle, diba? So I can also label this blue as my R position. It's from here going to the point there. So position vector R has negative y component, j hat, and then it has a positive x component. So I'd say that my R position vector R is positive x I hat minus y j hat divided by the R. Okay, so that's your R now. So that's our definition of R. So the electric field now, in terms of unit vector R, will be given by this relationship. Still from Coulomb's law. So you have K, and then you have Q over R squared, but you multiply it with R hat. So by doing this, by using this, your final answer will immediately give you the magnitude and the direction in component form, I mean. So in this case, this will give you the magnitude. You can get the magnitude and the direction. So if we put values here, yan, almost done. Okay, my son needs to use the laptop. So if we put some values here, like in the PowerPoint, if I'd say that if my R position R is, let's say we have, let's just say 0.3 meter I hat minus 0.25 meter J hat. So that's for your R. So ang R natin therefore is square root of 0.30 squared, Pythagorean, plus 0.25 squared. Okay? So, itong value na ito, yun yung ilalagay natin dito sa R. At saka ito namang si R sa baba, yung answer dito. Pahiram ng calculator, please. Ayan. So, and then if we say that, if we take Q is equal to positive, let's say 35, let's say microcoulombs. So that's 35 times 10 to the minus 6 coulombs. So let's solve this. Ayan. So we have square root of 0.3 squared plus 0.25 squared. Our R is 0.391 meters. So that's the distance between our source and our point of evaluation. So si electric field ngayon will be following this. So you have 8.99 for the K. I'm sorry. 8.99 to the 9th for the K. And then I'll have my 35 microcoulomb over the square of 3.91 squared. And then yung R hat natin, you have, gay natin dito. The R position is 0.30. I'll drop the unit first. Minus 0.25J over, saan na yun? So my R is over 0.391. Yan. So we simplify this now. Okay, let's try. So I'll have 0.3 divided by 0.391. So this will give us 0.762. This one will give us 0.767. And then 0.91 will give us 0.639. I hat 0.639 J hat. Further simplifying, okay, 8.99 exponent 9. 6 divided by 0.391 squared. So we have our multiplier here as 2.06 times 10 to the 6th times your 0.767. So you notice we still have our unit vector. So this gives the direction kaagad and it's in component form. So therefore, the electric field, they just multiply that 2.06 to the 6 times 0.767. So the electric field at point P has a positive X component, 1.58 times 10 to the 6th. And then don't forget the I hat. The unit is Newton per coulomb I hat. And then it goes negative Y direction, 2.06 times 0.639. So it goes negative 1.32 times 10 to the 6 Newton per coulomb joules. So if the magnitude and direction is not asked, you can declare your final answer as this one. But if it's asked, then you use Pythagorean theorem to get the magnitude of E. So you have EX squared plus EY squared, and then tangent for the direction. So I will leave it to you to solve the magnitude and direction. So let's see here, the electric field is going in the 4th quadrant. Let's go back to our drawing. Electric field is going to the 4th quadrant. So if we check, our source charge is positive. So whatever is the direction of the force, no? Kung maglagay ka dito na, the electric field is away. I'm sorry, the electric field is away. So from the source, here we draw now that the electric field here is in this direction. So this is now the electric field at point P. You use the Pythagorean to get the magnitude, and then you just tangent to get either this angle or this angle. Okay? Ayan. So that's it. Please solve similar problems on your own. I will see you later. Okay. Goodbye for now.